Welcome to Cosmic Echoes. Ready to dive deep? Today we're tackling time multiverses and the mysteries of reality.
It's going to be a wild ride.
That's for sure.
Yeah.
So strap yourselves in, listeners. Let's start with something that's been buzzing around pop culture, and
Yeah.
it's more than just sci-fi.
The simulation hypothesis.
Yeah.
The idea that we're all living in a giant computer simulation.
Yeah, exactly that.
Yeah.
Is there actually any, real science behind this, or is it all just Keanu Reeves in The Matrix?
Oh, it goes way deeper than Hollywood. It's a serious philosophical argument, and it all stems from a thought experiment by Nick Bostrom, this philosopher.
Okay, I'm listening.
He basically lays out three possibilities. Okay. So one is that civilizations never actually developed the tech to create realistic simulation.
Right. So we never reached that level of superintelligence.
Exactly. Or two, they do reach that level, but they choose not to create simulations for whatever reason.
Like they get bored with the idea, or they realize it's ethically kind of messy.
Yeah, something like that. But the third possibility, and this is where it gets really interesting, is that we are currently living in a simulation.
Whoa. So it's like we're either the programmers or we're just, NPCs in someone else's video game.
That's a simplified way of putting it, but yeah. And the crazy thing is, if you think about it statistically, if there are advanced civilizations out there capable of creating these simulations, then it's actually more likely that we're in one than not.
That's a bit of a mind bender.
Mm.
But, okay, let's say for a moment that we are in a simulation.
Mhm.
Why? Why would anyone go through the trouble of creating a universe like ours? Wouldn't that take an insane amount of computing power?
That's the big question. The why is really anyone's guess. I mean, some speculate that it could be for historical research, like a way for a super advanced civilization to understand their own past.
Like a cosmic history lesson?
Yeah, maybe. Or maybe it's just pure entertainment.
Yeah.
Like a video game on a cosmic scale. Or we
Wow.
could even be a giant science experiment.
Okay, that's pretty wild.
Yeah.
But is there anything that actually points to us being in a simulation right now? Like any clues?
Well, there's no smoking gun, unfortunately. But there are some intriguing parallels between how our universe works and how simulations function.
Like what? Give me an example.
Take quantum mechanics, for example. It's full of weirdness that kind of feels simulation-like.
Quantum mechanics. Yeah, that's where things get really strange.
Right, so think about it. You have particles that exist in multiple states at once until they are observed.
The whole observer effect thing.
Yeah,
Yeah, it's like the universe is waiting for us to look before it decides what's real.
exactly. And that's very similar to how a simulation might work. Like a highly detailed video game that only renders what the player is looking at to conserve processing power.
So our reality could be like a cosmic version of lazy loading.
Uh-huh. It's an interesting analogy. And then there's the whole thing about the universe being so precisely described by math.
You're talking about how the laws of physics can be expressed in these beautiful equations.
Right. Could that be pointing to a code-based reality? It makes you wonder. And another thing, the speed of light.
Ah, yeah. Einstein's big idea.
Yeah.
That always felt like a hard limit to me, like a cosmic speed limit.
Exactly. And maybe it's a fundamental constraint of our simulated environment, like the maximum processing speed.
I like that idea. It's kind of poetic in a way.
Yeah.
But let's be real here for a second. Simulating an entire universe down to the smallest particle would take an insane amount of computing power. Is that even remotely feasible?
That's a valid criticism, for sure. The
Yeah.
sheer complexity of our universe is mind-boggling. And then there are the ethical questions to consider.
Like, if we're just Sims in someone's game, do they even care about our suffering?
Exactly. It's heavy stuff. But hey, maybe it's time to move on from the simulation hypothesis for now and explore another wild idea, the multiverse.
The multiverse. Okay, yeah, I'm ready for that. What's the deal with that?
Well, the basic idea is that our universe, vast as it is just one of many, maybe even an infinite number of universes existing alongside each other. Imagine countless universes with different laws of physics, different particles, maybe even different versions of ourselves running around.
Different versions of me. Now, that's a lot to process. So where did this multiverse idea come from? Is there any actual science to back it up, or is it just pure speculation?
Well, believe it or not, there are actually a few scientific theories that kind of lend some credibility to the multiverse concept. One of the most prominent ones is the many worlds interpretation of quantum mechanics.
Quantum mechanics, again, always the source of the weirdest ideas.
I know, right? But this one is truly mind-bending. So the many worlds interpretation suggests that every time a quantum measurement is made, every time a particle chooses a state, the universe splits, creating a separate reality for each possible outcome.
So every time I make a decision, there's a separate universe where I made a different choice. Like if I choose pizza over tacos for dinner, there's a universe where I'm regretting that decision right now.
You got it. It's like reality is constantly branching out, creating an infinite tree of parallel universes with every little quantum event.
Okay, my brain officially needs a reboot. But hold on, let's say this is true. Why can't we see or interact with these other universes? If they're all out there somewhere, shouldn't we be bumping into them?
Well, the current thinking is that these universes are what we call causally disconnected. That means information or matter can't travel between them. They're like bubbles that are completely self-contained.
So no interdimensional travel anytime soon.
Not likely. But there are some scientists who believe that we might be able to find indirect evidence of these other universes, like maybe through anomalies in the cosmic microwave background radiation.
That faint afterglow of the Big Bang.
Exactly. They think there might be hints of collisions or interactions with other universes hidden in that radiation.
Wow, so echoes of other universes embedded in the fabric of our own. That's incredible.
It is. But there's another fascinating route to the multiverse that we haven't even touched on yet. You familiar with cosmic inflation?
Vaguely.
Hmm.
It's something about the universe expanding like crazy right after the Big Bang.
Right. In the first fraction of a second, the universe blew up like a balloon. But here's the thing. Some physicists think that cosmic inflation could have created what they call bubble universes. Separate, self-contained universes with their own unique properties.
So our universe is just one bubble in a vast cosmic foam.
That's the idea. And if that's true, then the possibilities for what these other universes might be like are truly limitless. Different laws of physics, different dimensions, you name it.
Okay, my head is spinning. I think we need to take a break from all these mind-bending concepts for a minute and come back to something a little more familiar. How about black holes? Everyone loves a good black hole story.
Black holes are definitely fascinating, and some scientists believe they could actually be gateways to other universes.
Really, I always thought of black holes as cosmic dead ends, places where matter and energy go to vanish forever.
That's the classical view. But there's this theoretical concept called wormholes that might change our understanding of black holes.
Wormholes. Those sound like something straight out of Star Trek. Are those even real?
They haven't been directly observed yet, but mathematically, they're possible solutions to Einstein's equations of general relativity.
Okay, so what exactly are they?
Imagine tunnels connecting different points in space-time, like shortcuts through the universe.
So like a cosmic subway system.
Haha, something like that. But here's where it gets really interesting. Some scientists believe that the immense gravity of a black hole could warp space-time so intensely that it actually creates a wormhole.
So instead of being a dead end, a black hole could be a portal to another region of space-time or even another universe.
Exactly.
Mind officially blown. I think I need a nap. But before we go, there's one more mystery we need to unravel. The nature of time itself.
Ah, yes, time. The one thing we all experience every second but can never quite grasp.
Exactly. Does time really flow from past or present to future, or is that just our perception? Is it a fundamental aspect of the universe or just something we humans made up?
Buckle up, listeners, because the next part of our deep dive, we're going to try to untangle the perplexing nature of time itself. Welcome back to Cosmic Echoes, where we're pushing the boundaries of what we know about the universe.
And grappling with some seriously big questions. Like, what is time, really? It feels so fundamental to our existence, but the more you think about it, the less sense it makes.
Yeah, it's slippery. It's something we all experience, but trying to define it or understand its true nature, that's where things get tricky.
So how did we even get to this point? I mean, what were some of the early ideas about time?
Well, for centuries, the prevailing view was that time was absolute unchanging, a universal constant ticking away in the background, like a
Sure.
cosmic clock.
Cosmic clock. Okay,
Uh,
I can see that. Everything running on perfect time, like a giant grandfather clock.
right. But then came Einstein and his theory of relativity, and he kind of threw a wrench in that whole idea.
Einstein had a way of doing that, didn't he? So how did relativity change things?
Well, his special theory of relativity showed that time is not absolute. It's relative to the observer's frame of reference.
So time is like a personal experience, not a universal thing?
Exactly. The faster you travel, the slower time passes for you relative to someone who is stationary.
Wait, really? Is that like a real thing or just a theory?
It's a real thing. It's been experimentally verified. We're talking atomic clocks on satellites running slightly slower than clocks here on Earth.
So time travel to the future is actually possible. I mean, not in a back to the future kind of way, but in a real scientific way.
Theoretically, yeah. If you could travel at a significant fraction of the speed of light, you'd essentially slow down your aging process compared to people on Earth.
So when you come back, everyone else is older than you.
Hmm.
That's both fascinating and terrifying. What about the past, though? Any chance of going back in time?
That's where things get much more complicated. Einstein's general theory of relativity, which deals with gravity, tells us that massive objects warp spacetime.
Warp space-time. Okay, you're losing me.
Imagine it like this: a bowling ball on a trampoline. The bowling ball is a massive object, and it creates a dip in the trampoline. That's what massive objects do to spacetime. They warp it.
Okay, I'm sort of with you. So how does that affect time?
Well, that warping affects time, too. The stronger the gravity, the slower time passes.
So like near a black hole, time would be moving super slow.
Exactly.
Mm.
But using a black hole as a time machine to travel to the past is still purely in the realm of science fiction. The conditions near a black hole are so extreme that nothing could survive.
Plus, there's that whole paradox thing, right? Like, if I went back in time and accidentally stepped on a butterfly, it could change the entire future, maybe even erase my own existence.
The butterfly effect. It's a classic thought experiment.
Yeah.
And yeah, paradoxes are a major headache for any theory of backwards time travel.
So maybe time travel is best left to the movies for now.
But let's go back to the nature of time itself. Is it a real thing woven into the fabric of the universe, or is it something we humans just made up?
That's the million-dollar question, isn't it? Some argue that time is an illusion, a construct of our minds, a way to organize our experiences, but not a fundamental aspect of reality.
We experience time passing every day. We see things change, we age. How can that be an illusion? Well, think about how our perception of time changes depending on our emotional state. Time flies when you're having fun, right? And it drags on when you're bored. That suggests that maybe our experience of time isn't reflecting its true nature.
Yeah, waiting in line at the DMV feels like an eternity, but a great concert seems to fly by.
So are you saying that some physicists believe time doesn't exist at all? Like at the most fundamental level of reality, there's no such thing as time?
That's right. Some believe the universe might be timeless.
A timeless universe. How does that even work? If there's no time, how do we explain all the changes we see around us?
Right.
Like the evolution of stars or the fact that we age?
There are a few theories. One idea is that time is an emergent property, meaning it arises from a deeper, timeless reality. So not a fundamental building block, but a byproduct of something else.
Okay, that's kind of trippy. And then there's that other mind-blowing concept, the
But
block universe, right?
exactly. The block universe theory says that past, present, and future all exist simultaneously. Time in this view is not like a river flowing, but more like a static dimension, like space. So the universe is like a giant four-dimensional block of space-time, and we're just moving along a predetermined path. Doesn't that mean free will is an illusion?
It raises some big questions about free will for sure. If the future is already set, are we really making decisions, or is it all just an elaborate play?
Wow, that's heavy stuff.
Hmm.
But let's stick with the time travel thing for a second. If the past, present, and future all exist at once, could we theoretically travel to any point in time?
Well, the block universe model doesn't explicitly rule out time travel, but it doesn't make it any easier either. The same challenges still apply. Paradoxes, the need for exotic matter, all that.
So even in a block universe, time travel might be more of a thought experiment than an actual possibility.
Probably. But hey, we've covered a lot of ground here, from the flow of time to time travel. Maybe it's time to shift gears and talk about something a bit more tangible. Or should I say intangible?
You're talking about dark matter, right?
Yeah.
The cosmic mystery that's been baffling scientists for decades.
Exactly. It's time to dive into the dark side of the cosmos.
Welcome back to Cosmic Echoes. It's the final stretch of our deep dive into time multiverses and the mysteries of reality.
And we've saved one of the biggest mysteries for last, dark matter.
Dark matter. The cosmic enigma that's been puzzling scientists for what feels like forever. It's like this invisible force lurking in the shadows of the universe.
It's a pretty apt description. We see its effects everywhere, but we can't directly observe it.
So how did we even come up with this idea of dark matter in the first place? What led scientists down this path?
Well, it started with some observations that didn't quite make sense. Astronomers were studying the rotation of galaxies, and they noticed that the stars were moving much faster than they should based on the amount of visible matter we could see.
So like there wasn't enough stuff to account for the gravitational pull that was holding these galaxies together.
Exactly. It was as if there was some unseen mass out there providing the extra gravity.
Enter dark matter, the mysterious cosmic glue holding the universe together.
Right. And the evidence for dark matter goes beyond just galaxy rotation. We see it in the way light bends around galaxy clusters. This effect, called gravitational lensing, tells us that there's way more mass present than we can account for with just the visible matter.
So it's like we're seeing the gravitational fingerprints of dark matter all over the universe, but we can't actually see the culprit.
Pretty much. And then there's the cosmic microwave background radiation, that faint afterglow of the Big Bang. The patterns we see in that radiation suggest that dark matter played a key role in the formation of galaxies and the large-scale structure of the universe.
So this isn't just some recent phenomenon. Dark matter has been shaping the universe from the very beginning.
That's the current thinking. But here's the real kicker. We still have absolutely no idea what dark matter is actually made of.
Well, that's not very helpful. So what are the leading contenders? What are some of the things that dark matter could be?
Well, scientists have come up with a bunch of hypothetical particles. One of the most popular candidates is something called a WIMP.
A WIMP? What is that? Like some kind of subatomic monster?
No, it stands for weakly interacting massive particle. They're thought to be particles that interact very weakly with ordinary matter, which is why they've been so hard to detect.
So like cosmic ninjas, sneaking around the universe without leaving a trace.
Something like that. And scientists have built these incredibly sensitive detectors, often buried deep underground, to try and catch a glimpse of a WIMP interacting with regular matter.
And any luck?
Unfortunately, no. Despite decades of searching, we haven't found any definitive proof of WIMPs or any other dark matter particles.
Bummer. So does that mean dark matter doesn't exist? Are we on the wrong track here?
Not necessarily. It could just mean our detectors aren't sensitive enough yet, or that dark matter is made of something even more exotic than we've imagined.
So the mystery continues.
Yeah.
But if we're having so much trouble finding these dark matter particles, are there any alternative explanations for what we're seeing?
Yeah, there are some scientists who think that instead of adding dark matter to the universe, maybe we need to modify our understanding of gravity.
Well, hold on. Change the laws of physics? Gravity seems pretty well established.
It is on the scales that we experience in our everyday lives. But on the vast scales of galaxies and galaxy clusters, some scientists believe that gravity might behave a little differently than we expect.
So instead of adding dark matter to the equation, we just tweak the equation itself. What are some of these alternative theories?
One of the most well-known is called modified Newtonian dynamics, or MOND for short. It basically proposes that gravity's effect is stronger at very low accelerations than what Newton's classic laws would predict.
So gravity gets a boost on cosmic scales.
You could say that. And MOND does explain some observations, but it's not a perfect solution. It still has trouble accounting for all the evidence we have for dark matter.
So we're at a crossroads. We have this compelling evidence for dark matter, but we're not sure what it is or if it even fits into our current picture of the universe.
It's true, and that's what makes cosmology so exciting. We're constantly pushing the boundaries of knowledge, challenging our assumptions, and trying to piece together a more complete picture of how the universe works.
It's a humbling reminder that for all our scientific advancements, we still have so much to learn about the universe.
Absolutely, and that's why it's important to keep asking questions, to keep exploring, and to keep challenging our understanding of the cosmos.
Well said. We've explored some pretty mind-blowing concepts today, from simulated universes to the nature of time itself, and now the enigmatic realm of dark matter. It's enough to make your head spin.
It definitely stretches the imagination, but that's the beauty of it. The universe is full of wonder and mystery, and that's what keeps us coming back for more.
Couldn't agree more. So for all you cosmic explorers out there, keep looking up, keep questioning, and keep searching for answers. And if you want to delve even deeper into these fascinating topics, be sure to visit GalileoWhispers.com. Until next time on Cosmic Echoes, keep those minds open, and remember, the universe is a vast and wondrous place waiting to be explored.